Software patching needn't be a can of worms. The theme of this conference, as I'm sure everyone knows, is to focus on unanswered questions in SRE. And for me, software patching does not feel like a solved problem. Next slide. Come on. What am I not talking about? The anti-talk. I'm not talking about patching, putting cables into consoles. I'm not talking about using the Unix patch utility. If you still do that, all power to you. I'm talking about software updates. These are my thoughts. I'm not presenting any particular work. Opinions gathered over several years. Trademarks belong to other people, as do copyrights. I hope you take from this talk the bits which latch on in your mind, make sense to you in your organization. So, good talk starts with a hands up. Hands up if you use third-party software. No need. Everyone uses third-party software. It's in this laptop, and that TV, and that projector, and the steerable lights that are around the room, and it's in your phone, and it's in your car, and it's in your doorbell, and it's in your BIOS, your operating system, libraries, frameworks, applications, containers, App Store. I couldn't find a good quote from Churchill or Shakespeare or Abraham Lincoln on software patching, so I made one up, which I'll read to you. There's no record of what third-party software or versions we use. I don't know what updates are available, and of those, which are the most important. It's hard to get downtime on production systems. There's no test environment for this. I'm scared the upgrade will break stuff, and when it does, rolling back will be even harder. If any of that seems to apply to you, then I propose automation is the solution. There is a Dilbert cartoon that's relevant to this, but it costs $35 for me to show it to you, and it's not that funny, so I'm going to skip it. First section, how do different vendors approach patching? So we can have a live demo, that's always fun in a talk, but you can do it. If you have an Android phone, follow along with me. If you have iOS, then you'll have to translate these. But if you want to take out your phone, then you can go to the Play Store, and then in the menu, you can go to My Apps and Games, and then in the Update section, you'll see that, well, on my phone, I can have Maps Preview, that's a secret, I shouldn't tell you, and Google Calendar are now available, and then press the Update button. You don't have to do that, but that is a fully automated software update system. It exists on Android phones, on iOS, desktop operating systems, macOS and Windows. It probably exists in your TV, and your web browser, no doubt, pops up frequently to let you know that there is an update available that it would like to apply. Second way of managing it, kind of semi-automated. This is where the software will have some awareness that it might have been overtaken, and some tooling to allow it to detect that. Either built in or as a sidecar functionality with package managers can do this. Certain VoIP phones from Polycom will go and tell you that there's an update. I don't just mean that there's a URL to a help page where you can go and check it. I mean that the software has some facility to reach out to a service, probably from the software vendor, and do its own analysis. Now, this gets muddy in territory where you might not have direct internet access from your devices to be able to look up updates. The last form I would describe is a fully manual process where there's absolutely no help and you have to do all of the legwork yourself. Maybe you're downloading a tar file, maybe you're building software from source, maybe you're using some commercial software that just doesn't know anything about the state of its own ecosystem. If you have software like this, consider the maintenance cost that it puts on you to be able to keep it up to date. Maybe factor that in when you're assessing new products, new software coming into your organization. Can't see my timer now for my live demo. Okay. A case study that covers all of these is cars. The screenshot I have there is the Ford ETIS homepage. All large car manufacturers have a site like this. There's a link. I'm not going to click anything now, but if you get these slides later, you can click through. You can find all the ones you would expect. Ford calls it ETIS. Volkswagen calls it Irvin, I assume is the pronunciation. But these are paywalled sites where independent garages, or if you want to sign up, you can go there, register for an account, and get all of the software updates that apply to your gearbox and your power steering and your engine management system. I don't just mean the radio and the entertainment part, but the bits that make the car go. I would classify that as the fully manual end of the scale. By contrast, Tesla has over-the-air updates. So you can just reach out to the internet, pull down a new feature, and there you go, your automated driving, maybe. As a couple of cautions I want to make here. Is this mouse pointer working? There we go. You'll see that in order to use this website, you need Macromedia Flash Player, Adobe Reader, SVG Viewer, probably not, Java plugin. Some of those pieces of software bring their own aspects of update management onto your desktop computer. Have another warning that if you're trying to make your car internet connected, learn from Chrysler's mistake with Uconnect, which unfortunately allowed people anywhere on the internet to control your accelerator and your brakes. This really happened in 2014. Go and read the Wired article. It's terrifying. The different approaches on releasing updates, some vendors will take, include long-term support bases. Do the vendors distinguish between, here's a security fix, here's a bug fix, and here's a brand new feature? They call it different things, so I've given some examples. Firefox calls it extended support release. Linux kernel has its own long-term branches. Windows 10 calls it the long-term support channel. Cisco's NXOS calls it the long-lived release. But all of these are basically that the vendor has announced upfront that the lifetime of any particular version of the software will be longer. This de-risks for you, the end user, taking an update and thinking maybe something will go wrong. No, it's supposed to be the steady and safe long-term support channel. The last example there is that if you use operating systems towards the end of their life, they may go into a maintenance support mode or an extended support mode with declared dates so you know when you need to stop using them by. The alternative is a single update track. The phone example earlier is a good one there. I wasn't given an option on do I want the support branch or the feature branch. I just told there is an update. Okay, second section of the talk is how is automation? This is the big pitch I'm making. Automation is the only sane way to do this. And as end users of buggy software, how can we help ourselves? So here is my recipe. I'll go through it stage by stage. It's learning what you have, learning what there is, assessing what there is, planning to roll it out, planning to roll it back, and then repeating it forevermore. First stage of that, inventory. So, do you know which third-party software you're running? This is one of the easier sides of the automation task. There's tooling to help you. If you run Dell systems, then Dell will give you Open Manage to make your life easier. You can probably roll your own. Surveying versions of software is reasonably simple, but I'll ask you two questions. Is everything that you need to survey network accessible? If you need to get past a firewall or different data centers, you may need to survey from different points. If it's a car that you own and want to include in your inventory, you might have to go and physically survey it. And I classify as zombies equipment which is off but you still intend to use. For example, you've got a network switch in a rack and you've got a cold spare ready to go for as soon as it breaks. Are you keeping your cold spare up to date with the same versions so that it's ready to slot in? That should also be in your inventory. I once spent pretty much an entire day upgrading a Brocade switch, which could only do step releases. And I got an RMA device which needed 6 upgrades. Don't do that. Now you know what you have, you need to know what's available. There used to be a tool. I was writing this talk and went to look for it, called Microsoft Security Baseline Analyzer. I find that's no longer available, but has been replaced by something called Windows Update Offline Scan File. But it's basically get a load of metadata onto a host that you're interested in, and then run a tool to assess what is it that I haven't applied in terms of available updates. Solaris provides patchdiag.xref, if anyone is still using Solaris. This can be a difficult task if the vendor provides no metadata. You'll have to go and find it all yourself. Well, you can delegate this part to a packaging provider. If you have a distro that comes with packages, then somebody else has taken on the burden of tracking what available updates there are and getting that metadata to your host. Okay, so now we know what we have and we know what's available. Should we apply every update? Maybe. We can classify these into it's a critical security fix. We probably want to do that sooner. At the other end of the scale, it's a bug fix for a feature that we never use. Okay, we might pass on that or just roll it up into a sometime, maybe never update. You can do this in-house, but I would strongly urge you to delegate the assessment stage to another provider. Maybe it's the vendor themselves that come up with a simple labeling scheme, critical, recommended and optional, I remember seeing from some recent Dell updates I was looking at. Your Linux distributor, for example, will do this. If you look at RPM updates, those are all labeled. You'll notice I haven't said containers yet. I haven't used containers hands-on, and there is a slide about them later, but I realized saying this that it feels a little bit old school already. There are third-party providers, as you heard in Jennifer's talk just before this one. Is it SNIC or SNIC? That will do open source assessments and classification to tell you what the urgent updates that you need are. It's just safe to assume that every version of all the third-party software that you're running, sooner or later, will have a critical security update. And then when it does, you'll be ready. Planning. So now we know what we're applying. When should we do it? Is it a disruptive upgrade that needs a reboot? Do we need some downtime? Do we have downtime already in scheduled maintenance windows? Are we going to have to go around asking people, when can we turn this off? If you have scalable systems, what level of redundancy do you have? If it's auto-scaling, this is all fine. But if you have no spare capacity, you'll be doing everything at 2 a.m. on a Sunday. If you've got one spare system, data center, you can tolerate a single failure. If you're N+2, you can tolerate a single failure and have one out for maintenance. Seems ideal. If your system horizontally scales, are you able to take out each node at a time to apply an update, or do you need to knock the whole system down, have a flag day, and move from version 2 to version 3? It's up to you to decide when to apply the updates, and there are better and worse times for these things to happen. This is embarrassing. My laptop now wants to apply updates right in the middle of a presentation. It's not the best time. Whenever I expound these ideas to people, sometimes the response is, it's risky. Applying updates, it's making a change, it has risks. Yes, it does have risks. Proactive patching has risks, including just doing the wrong thing, pushing the wrong change, any fat finger error. A startup bit rot I would describe as some bugs only show up when you restart systems. Fan failures and other hardware issues, but if you only have a boot time issue, you may have made some change weeks ago that you've laid the groundwork and you've set a trap for yourself. When you do the next reboot, you may uncover that. Proactive patching can genuinely introduce new bugs into your systems from third-party updates. It's a possibility, so plan for it and you'll be in a better place. I would argue that this is infinitely preferable to reactive patching. Why? Here are some reasons. If you only patch reactively, then you may need to jump a major version because circumstance forces you, and now you've got some larger change to handle. You might find that you need a bug fix, but oh dear, that version is no longer supported. If you only do it reactively, then your staff will be tasked with unfamiliar work. It might be a 20-step manual process that they don't do very much. And the last point, I really want to emphasize this, is that if you only patch reactively, you're ignoring all the other users in the world who are using the same software as you. What do I mean? One of the most frustrating things to get beeped for and then triaged down to a root cause for me is, oh, this system doesn't seem to be behaving. Let me look into it. I'll look at the logs. I'll try to reproduce it. Great, I think I understand it. Go and check the vendor's updates on the website. Oh, this was already fixed. I needn't have got paged if only I'd taken the update. Everyone else in the world using the same software as you is encountering the same bugs, possibly, reporting the same bugs. The vendor is going to act on those reports. You get the benefit of everybody's research just by taking the patches. Here's a case study of proactive versus reactive. You may remember this. There was an update in 2017. It's called MS17010, and it disabled SMB v1. This is the file sharing built into Windows. Microsoft classified that update as critical remote code execution. You would think that would be pretty urgent then to patch in your systems, but if you were the NHS, the National Health Service in the UK, unfortunately, just shy of 2 months later, the Wannacry attack infected a large number of systems and popped up this screen. What's this? It's a ransomware demand. It's asking for $300. It would like it to please go to that address. Otherwise, the machine is toast. You can wipe it clean, but your files are gone. In the beginning of 2018, a post-mortem was published which included this quote. It wasn't to do with out-of-date systems. They comment that 2% of the machines were running Windows XP, which had gone end of life 9 years earlier. But the rest of it, it was mainly just lack of patching that meant that this worm could infect all of the NHS PCs and other organizations. Last stage of the recipe, actually doing the rollout. And the rollback, maybe, if it goes wrong. There's lots of people taking photos, which is good, but I will send this link for the slides around. It's much easier to justify doing a rollout if you know that a rollback will be as simple, should it be needed. How are we going to test the change before it goes live? Well, unfortunately, sometimes it's not really clear what you're taking and what the changes would be. Can you do a functional test? If you can't, then we're just relying on regression, stability, and performance. What do I mean by that? When we put out the new version, it must not fail any more tests than already it fails, nor must it crash, nor must it exhibit any more errors than it already does, nor must it use 50% more CPU. I put my percent in the wrong place. An example of this would be the mitigations that were released for the Meltdown and Spectre issues last year, some of which reduced CPU, in some use cases, not all, reduced CPU performance by 19%. That's a capacity issue right there, and a tough trade-off to choose, do I take the critical security fix, or do I need that capacity? You can gain confidence that an update will work for you by applying your good QA practices and continuous integration, and or an incremental rollout. Start at 5%, or start with the canary, then go to 5%, then 15, whatever numbers you feel will eventually take you to 100. I'm going to skip that note because I come back to it. And now you've done all of that. Sit back, relax, and do it all over again. My assertion is that there is no bug-free software. If you believe me, then the corollary is that eventually all maintained software will have an update available. It's a never-ending task. Third section. The ideas here are supposed to trigger in your minds, maybe we could do this. If you think you could, good, make a note. You may already have a team inside your organization that's doing some of this. If you have security, then they will care about the kind of vulnerabilities that have a name attached: Dirty Cow, Spectre, Heartbleed, Shell Shock. When they're assessing these, they'll want an inventory of what systems need to be patched, what vendor updates are available, when can we plan doing this, do we need the downtime, does it need to reboot, all the things I discussed earlier. Why stop at vulnerability handling when it's the same process for all updates? I'm not saying give this to your security team, but apply the same things that they may already be doing in a more comprehensive manner, considering all the third-party software in your organization. Everything dies. Some commercial software will tell you several years ahead. Some open source software might simply stop having updates or lose a maintainer. You go and check for new releases and there haven't been any for a year. When I was putting this together, I tried to find the oldest version of some still supported software I could. My mind turned to an IBM mainframe, and I found VM370 was released in 1972, and ZVM was released in 2018. This is continuous compatible software. Most software does not last for 48 years. Do you know when your third-party software is going to go end of life? When it does, is there an upgrade? If there is an upgrade, that's good, but it may be a major task, updating all the Windows desktops in your organization. Finding this nugget of metadata out is not easily automatable, I'm afraid. I don't know a good recommendation where I can say, go here and there's a large list of it. I have an example of 2013, Oracle started to introduce expiry dates in their desktop JVMs. You would fire it up, and it would try to do an online check, but then it would fall back to the semi-manual mode of saying, I'm quite an old version of the software, and they built a date into it at which this pop-up would appear. It would then still work, but it was to prompt you to then go and have a look, because there are so many JVM updates that there's probably a security issue that you're missing if your JVM is a year old. Next case study. I don't know if any of you have young children. If you do, you may be familiar with the Octonauts. If you don't, I'll summarize. It's Captain Barnacles at the top. He's the leader of the Octonauts. They go around the sea. In the Octopod, it's a kind of submarine. They help sea creatures. Why am I telling you this? In the Octonauts Explore the Great Big Ocean, the story begins saying what all the Octonauts are up to that day, and it's pleasing to see that Dashy Dog was updating the Octopod software. You can see there it runs Octo OS 8, and it's on disk 4 of something. Let's zoom in. You see some obvious problems here. The Octopod needs 5¼ inch floppies and appears to be using a Commodore 1541 disk drive. Clearly a problem, as these were discontinued in 1995. If you need to buy that media on eBay, I was looking yesterday, it's about €3 a disc. So obvious issues that the Octonauts need to address. Release notes. Typically awful, sometimes good. Do you even have time to read them all? A good release note will tell you about any CVE, security vulnerabilities which have been addressed. Maybe it will tell you the classification that the vendor puts on, critical, important, or optional update. Or maybe it will look like this. I won't name names, but that is a fairly common update note that I see for Android apps. What do we do with that? Should we take the update? Probably. Can we test the update? No. You're just expected to click through. In this case, I think it would be justifiable not to apply updates for some amount of time. Thinking back to the many eyes thing earlier, other people will probably jump earlier than you. So if you're not sure about whether to take an update right now, maybe wait a month. If there is a problem, other people find and report, you can expect that that update may be withdrawn or superseded. If it hasn't been after a month, then that's some indication that, okay, maybe it's fine to apply. Which of these things do you already have you can build upon? Do you have an inventory of your systems? Do you have a continuous integration pipeline? Do you have a release engineering process which allows you to do easy rollbacks? The automation that I'm advocating here is not all or nothing. If any of these bits seem useful, start doing them. And as with all good habits, the second best day to start doing them is today. You're probably not going into this with a completely blank slate. Rather, it's retrofit work where benefits are realized incrementally. If you do all the things I'm advocating, that's not only to the benefit of software patching. There are virtuous side effects. You will have good inventory, you will have good testing, you will have good deployments and rollbacks. I realize that I've only touched the surface of a larger area, so stuff that I haven't covered here includes, you can click on these on the slide versions. The Linux Vendor Firmware Service is an initiative to help your Linux server stay up to date with standardized, I think they're UEFI applications, but a way of doing the cataloging, the awareness and availability of what updates you can get. You saw in the previous talk maybe the Azure Security Center. I wasn't aware of that, but the link there goes to the Google equivalent. You can have systems that scan your containers if you don't know what's in that black box, things that can help to pick it apart. Learn from Huawei and the proliferation of OpenSSL versions. This was a report from the HCSEC Oversight Board that, to quote, an unmanageable number of versions of OpenSSL had been imported. If you take third-party source code into your product, try not to have lots of different versions of it. If you ship third-party software with your product, how often are you checking for and publishing changes that may be security issues to your customers? That's the end. The 3 bullet points there are the questions to ask yourself. But if you have any questions to ask me, please do.
We have time for some questions. I can either bring the microphone to you, or you can come up to this one or that one, if anyone has one.
You don't have to sing it.
Thank you for saying that. I have probably a strange one. Why do you make a distinction between what Android apps do via Play Store or Linux via Package Manager? You say one is fully automatic, one isn't.
The question is, what's the distinction between the fully automated Android App Store and the Linux distribution? I think the difference I'm getting at is that you possibly do, possibly don't, take those updates anyway. The thing I showed you earlier was because I've changed my phone settings not to automatically apply. If I'd just taken it out of the box, I wouldn't have those prompts to pull the update. It would just already have gone on. The ways I've worked with Linux systems don't automatically put new software onto your server without human intervention to review when do you want that to happen.
Well, these days you can actually do it. Like with Debian stuff, you can have the unattended upgrades, but it's opt-in, not opt-out.
Sure, so you can move along the scale from full to manual.